we're going to look at some more factoring by grouping. So we've looked at factoring by grouping with quadratics, but we're going to look at it with some higher order polynomials now. For example, x to the fourth minus 2x cubed plus 8x minus 16. And just like everything else we do with factoring, always check for a greatest common factor first and factor it out if we can. But there is no greatest common factor here. It would have to be a factor in all four terms. So with factoring by grouping, we're going to split the four terms in half because factoring by grouping, we do need to have four terms. So we're going to split this into two pairs of terms. I like to do that with a squiggle or a line. Some people like to do it by underlining each pair. So I'm going to look at my first pair, and I'm going to factor out a greatest common factor in that first pair. So x to the fourth and negative 2x cubed, my greatest common factor is x cubed. When I factor out x cubed from x to the fourth and minus 2x cubed, I'm left with x minus 2. And then I'll look at my second pair, and I've got 8x minus 16. My greatest common factor here is 8. Now my third term in the four terms is positive, so my greatest common factor will be positive. If that third term had been negative, I would have factored out the negative, and my greatest common factor would have looked negative. And then when I factor 8 out of 8x minus 16, I will be left with x minus 2. So I have a common binomial term here. That's what I should get. If I don't, either I made a mistake or this cannot be factored using factoring by grouping. Okay, so for factoring by grouping to continue, we need to have that common binomial term. So now we will factor out that common binomial term. So I'll factor out the x minus 2. So I usually put that out in front. And then I'll put second parentheses, and then I'll put what's left once we factor that out of each of those terms. So from the first term, I'm left with x cubed, and from the second term, I'll be left with positive 8. So I'll have x cubed plus 8 in my second parentheses. And then factor any nonlinear factor if possible. So a nonlinear factor means I'm going to have an exponent on one of my variables. And my nonlinear factor here is x cubed plus 8. This is a sum of cubes, and we've seen how to factor sum of cubes. So we're going to factor that again really quickly. So x minus 2 is already factored as much as it can be. There's no greatest common factor there. So with x cubed plus 8, what cubed is x cubed? X cubed. What cubed is 8? 2 cubed. So here my a is x and my b is 2. And then if I'm substituting that into my sum of cubes formula, my a plus b is going to be x plus 2. And then in my second parentheses, I'll have my a squared minus 2ab plus b squared, which will be x squared minus 2x plus 4. So my original x to the fourth minus 2x cubed plus 8x minus 16 factors to x minus 2 times x plus 2 times x squared minus 2x plus 4. Remember, with that sum and difference of cubes formula, that last trinomial term is not factorable unless you did not factor out a greatest common factor to begin with.